Well, hello everybody. Welcome into Great Atmosphere here on January 26th of 2024. Wanted to get started today by looking at the true color satellite imagery from the College of DuPage website and take a look at what we're looking at across the contiguous U.S. Currently, we have our next main system coming into the Pacific Northwest by way of a North Pacific jet extension. That atmospheric river is starting to get going and dumping quite a bit of precipitation over Northern California up into the Olympic Cascadian mountain ranges, along and still overrunning actually onto the plateaus as well. We have our next big troublemaker starting to make its way in the panhandle region of Texas and Oklahoma, starting to get some really tight spin actually over in the north central Texas regions, and primary convection being initiated along the Red River border. And then we actually have quite a bit of convection here in the Gulf of Mexico that's robbing the southeast of a lot of the convection necessary to create a significant cloud deck. We'll talk about that in a second, but we also have our receding fog line. I know earlier in the week we talked about how the fog extended all the way to the Wyoming and the Coloradan borders. Now we can see it gradually starting to move into central Nebraska and central Kansas. This area has pretty much been completely inundated with fog for the past week, so it'll be good for them to see sunshine again. And then we have the remainder of our previous system starting to still have some lake effect residual moisture in the atmosphere that's still dumping quite a bit of snow in the upper elevations of the Northeast and the upstate of New York, along with southern Ontario and across central Michigan. And then that brings us to the southeast, where we thought that we would have a pretty strong cloud deck today. Initially, earlier in the week, excuse me, we thought that it would just be cloudy for essentially 7 straight days, and it would limit a lot of the potential radiational heating that we would get, because we were just not going to get enough sunlight to hit the surface and heat us up at the surface. That has proven to be incorrect for today, because as you can see from the True Color satellite, we can see green. It represents land, and anytime that you can see green, that means it's not being interfered with the white clouds, as you'll see over in Oklahoma and otherwise. So that means that the sun is hitting the surface, and it's heating up the surface quite rapidly. If you actually, we can take a look at our current temperature map. This is pretty insane. We have 80s along the Atlantic coast and the Carolinas, and then also we're getting into the mid-70s in the Piedmont, all the way up to Washington, D.C., in the Chesapeake Bay area, 75 degrees. And remember, it is January 26th, hitting that. these are getting these are some ridiculous numbers. To say that in Washington, D.C. in January is just as warm as Jacksonville and St. Augustine, Florida, is kind of amazing, honestly. But that's just is the nature of the synoptic pattern that we're in. And this has increased dramatically over the past 3 hours as the sun continues to soak in. And we're actually starting to see quite a bit of daily records starting to be broken. And we can see this for the last 24 hours, I believe. And it ends with a bunch of these red circles with white outlines, and that denotes a tying or breaking a monthly record high. So this is denoting any time that you see one of those red dots. It is the highest that temperature has ever been in that particular month on that day. So we haven't seen any all-time record highs yet. That would be the hottest it's ever been ever on this specific day. But we are getting close, and I'm particularly looking at Charlotte right now. Charlotte is currently sitting at 71, forecast to be 73. But we take a look at what the record is for today, and the record is 75, and that's a record that's stood since 1950. So that would be quite significant, and we still have, I'm recording this at about 2:30 in the afternoon, so peak heating of the day still is not here yet. That'll be about 4 o'clock. So actually it might be about 3 o'clock this time of year. So we'll see what the temperature looks like. It'll be a close one, but ultimately very, very hot here in the southeast due to there not just being any clouds today. And ultimately that might work against us as we move forward into tomorrow, as we have a elevated severe threat as well that we need to address, and we'll get to that in just a little bit. Taking a look at our current radar reflectivity, it's a pretty calm day. We knew that this particular system, when we started in the week, would come in waves, so we knew that Wednesday would be a quite significant storm system for the Ozarks and the Texarkana region, along with Louisiana and Mississippi had a slight to severe risk that was issued by the SPC going into yesterday. Now we're just seeing the beginnings of that low pressure center starting to make its way across the Red River, working its way into the Dallas Metroplex. as we also see some rain starting to linger off of the massive convection that we saw from the satellite view. It's starting to make its way off into the southern bayou regions of Louisiana, and we'll soon get into the in southern Mississippi as well. So relatively calm day from a weather perspective, but it's not going to remain that way for long, especially going into this weekend. We're going to take a look at what the Schreff plumes have to say about our temperatures and rain chances going forward, and we're just going to give this just a second to load. Sometimes it's a little slow. Oh, we're very slow today, evidently. Let's do one of these. Okay, so now we got it. So this is what the Schreff plumes are denoting for temperature over the next 3 days across the. This is particularly in the Charlotte region. You can see that it's still predicting. This is not going to be accurate anymore, but of course we're looking at out in the days ahead, and this is all looking at confidence intervals. It's saying that the mean average is about 72, which is exactly what we're at right now. So the Schreff plumes are saying that we are done heating up in the Charlotte area for the day, which we very well might, due to the time of the year that we're in. The sun's starting to already technically set, and as we move forward, you can see there's a gradual decline. As we move forward in time, we go into the mid 60s tomorrow. That's where we probably should have been today if the cloud decks had been in place, and the cloud decks will certainly be in place for sure tomorrow. But then after that final low pressure center starts to make its way over us, and the subsequent cold front comes through, that's when our temperatures take quite a significant dive, and we are expecting highs back to more of a seasonal range, usually around this time of year in the southeast. We're in the mid 50s, if not a little bit lower than that, and that's right back to where we are going to be in the next few. So we take a look at that, and then we'll see. Maybe let's just hop around here for a little bit for fun. So we got the total QPF that we're expecting. Quite a difference in confidence here. So what the cool thing about this site is you can take away outliers. I mean, these are not like actual forecasts that human beings do. These are all computer generated models. Sometimes they get a little bit carried away. Like this one that wants us to have half an inch of rain by the end of like this evening. That's probably not a realistic model, but unfortunately it does contribute to the overall mean line that we like to base our forecast on. So we're going to actually take away this one. So what is this one? That's the MBP1. So we can just uncheck the MBP1, and then this is the ARN2, and we'll take away the ARN2. We'll take away the ARP5, and we'll just see where that mean kind of lands. Not a lot of confidence, but we do have a good range. I would say between this ARP3 and this ARN1, that's generally the range that I'm going to go with. So we're looking at about 0.7 of an inch down to about 0.5 of an inch. That's quite tight, and we'll call it a nice 0.6 of an inch as what we're expecting in the Charlotte region. So that's just kind of how we go about forecasting. Raleigh is looking about around the same, about 0.6 of an inch, maybe a little bit more. Greenville, South Carolina, since it's a little bit higher in elevation, we get a little bit more upslope flow for it, so we're expecting about an inch there. Wow, this is the ARP1 went a little crazy, had double the mean. That's fun. And then we can take a look at maybe some of our instabilities. They're a little bit less reliable, but it does give you an idea of timing. We're looking at least for Greenville and the GSP region, the max for the most unstable layer of Cape. That's usually more elevated Cape, so higher supercellular thunderstorms typically. Highest chance to get in about the 400-500 region, which is more than enough to spark off a severe thunderstorm or two. For the most unstable regions of the atmosphere, is looking at 6Z on the 28th, which would be, I believe that is Sunday, 6Z. So yeah, that's about middle of the night, unfortunately, on Saturday night. So this will definitely be something that affects our area here in the latter portions of Saturday. Hopefully, if there is any severe weather, that we make sure that it's during the day, so if there's any tornadoes, people can actually see it, and that no one gets surprised. But honestly, a lot of it comes down to the nocturnal heating. I know these values were considerably lower before we had today, and we got so much radiational heating just heating up the surface of the in the boundary layer of the atmosphere. So it's nice today, but we're definitely gonna reap what we sow here as we move forward in time. Just want to take a look really quickly on a synoptic level. Actually, this is a global level, just to see what our polar vortex looks like. You can see that this primary upper level stratospheric low has completely weakened. This was this rotation right here actually was it was the primary contributor to our sudden stratospheric warming event that occurred over the past early parts of January, I'll say, that ultimately displaced this polar vortex over into the Scandinavian and Siberian regions, and ultimately was the reason that we had such a huge cold burst at the beginning of the month, just because instead of all of that cold Arctic air being trapped like it is right now due to those high upper level winds and that donut shape, all the cold air is effectively trapped up there right now. That was not the case as it was fully displaced and was sending cold air and all fits and valleys and whatnot all throughout the course of all the continents. So we don't have that situation right now. So we have our cold, dry, upper level Arctic air up in the Arctic. And then we have our warmer, more moist mid-latitudes staying that way as well. And it's generally creating a much more mild atmosphere for everyone here, at least in the States. So that's what we're looking at for the polar vortex's point of view. But the other thing that is a big major talking point right now is that North Pacific jet. Now, the North Pacific jet is a primary atmospheric river indicator, and ultimately this time of year is a very big indicator in terms of what kind of weather we're going to experience here in the United States. So currently, if we take a look at where the crux of the Pacific jet currently is where that hottest pink is. We're seeing winds. This is at the upper levels of the atmosphere, about 250 millibar height, so very, very high. 10 kilometers, I believe that's about. Maybe a little bit higher, I'm not sure. That is ultimately based currently off of the coast of Japan. That's what we would call a jet retraction. And we usually see in the southeast U.S. the results of said retraction existing about a week in advance, because or a week in the future. So if we see a jet retraction period now, we would start to see jet retraction type weather in about a week. So what we're currently experiencing in this current setup that we have is a jet extension weather, because earlier in the month we experienced the North Pacific jet extension, where this jet max was all the way over near the coast of California. And when that happened, it really worked to destabilize the atmosphere and ultimately created the very tumultuous weather situation that we have this week, where it's very rainy, wild temperature swings. All that kind of stuff is due to that extension. Now we're in a retraction, which means that we can expect maybe next week to have a little bit more milder and calmer weather over the southeast United States. But as we'll see here in a second, that retraction will not last long. As we go forward in time here, we can see that gradually going Sunday, Monday, you can see the center of that streak is slowly making its way closer and closer to the California coast. And it's an interesting little phenomenon that we have going on here, because once the primary jet extension streak comes over to the eastern Pacific like this, we see split flow. Right, so we have a high pressure center that's based over the Rocky Mountain Plateau, and then we see the overall jet kind of diverge over both the Pacific Northwest and the Desert Southwest. Now, ultimately, wherever the low pressure centers are, and we've talked about quasi-geostrophic theory before, which essentially is like if you split a jet streak into 4 quadrants. So in this case, we're going to split it like yay. The left exit region in the northern hemisphere is typically, at least on a synoptic upper level point of view, will be the area that has the highest chance for producing a good amount of convection. So wherever that particular low level dip right there is, and that's a pretty significant low pressure system at 983 that it's forecasting there in the 250 millibar level. Wherever that ultimately lies is where we would expect to see the heaviest amount of convection and ultimately the highest amount of precipitation. So as we see on midweek on Wednesday, ultimately the Pacific Northwest gets to be a big part of that, but then it starts to move further south, and you see that quite significant dip right there. That significant trough is actually going to contribute to a mild to moderate atmospheric river event for the southwestern tier of the U.S. Now, there has been quite a bit of controversy in the meteorological Twitter space over the past couple of days, and ultimately it resulted, I'm not going to share the tweet, but ultimately a person who thought they were doing a good service thought that it would be smart to alert everyone that, hey, big atmospheric river events like the one that we might or we probably will experience here next week could be a whole lot worse than it actually is ever going to be forecasted to be. And the end result is that the Central Valley in California will essentially become a new Great Lake. While I'm not going to say that that's not entirely possible, it's just incredibly improbable. And specifically for this particular event, we are not seeing any indicators that the biblical, Genesis chapter 7 type floods that particular person was predicting is ever going to happen in that respect. Just because so many different variables and so many different outliers and so many different bad things have to happen all at once in order for that particular setup to happen. So don't believe everything you see on the internet as Internet 101. But we can take a look at what the Climate Prediction Center has out for the next 6 to 10 day precipitation outlook. And they put out this guidance regularly from the Weather Prediction Center, just pretty much outlining that there is an impactful atmospheric river event that'll be coming in starting next week. And it'll outline where and when we expect to see the highest amount of both winds, snow, and precipitation. And for the entire area, we see heavy precipitation is forecast from February 2nd to February 6th. And then we have the snows up into the upper elevations as well. And high winds will obviously be there because with being along the ocean, being along the oceanfront in general, you're going to have higher precipitation just because it's not being interfered with at all as it comes onto shore. And then also, as we come off of the Rocky Mountain Plateau, we get downsloping winds, very, very common in the Sierra Nevada regions. Not saying that's the Sierra Nevada by chance, but just coming off of the off that Rocky Mountain Plateau, you'll get much higher winds as air expands adiabatically. So that is what they're generally looking at. Nothing here says, we will no longer have a Los Angeles by the end of the day, or Lake Tahoe will soonly become Ocean Tahoe. I don't know, but that ultimately it'll still be quite a big precipitation event, and the area does need it just because that particular region of Southern California and the Southwest has been a little bit rain starved. Actually, the Pacific Northwest has kind of taken up all of its juice, and it'll be good to refresh those reservoirs before we get into the dry season in the Pacific, in the Southwest of the United States. But enough about that. We're going to talk first about what we're expecting here in the Southeast, because this is a Southeastern related channel. So this is looking at the Day 2 convective outlook. This will ultimately be what we're expecting to be the main severe elements going into tomorrow. We see that there is primarily a slight Level 2 out of 5 risk for severe weather. All hazards are in play in this particular region. We have a 5% chance of tornadoes. We have a 15% chance of severe level winds, and a 5% chance of hail. And the primary areas that they've outlined in general are under this yellow region. So pretty significant metro regions in this particular region: Birmingham, Montgomery, Mobile, Pensacola, Florida. And then the marginal risk, the level 1, will also be extended into the Charlotte, GSP, and Atlanta regions, along with Huntsville, Alabama, and I believe that is Murfreesboro, Tennessee, if I remember correctly. Probably not. I should know that, actually. Clark's? Where Lee University is, that's all I know. So effectively in those particular regions, along close to Panama City Beach in Florida and extending out into New Orleans, that is going to be under the marginal threat for tomorrow. And essentially let's see what they're looking at. So what we do when we're doing a severe mesoscale analysis, we like to take a look at everything from the upper levels and work our way down. So we'll take a look at the NAM and see what we're looking at the 300 millibar level at the upper levels. And we can see that there's a quite significant trough that it's starting to make its way from that panhandle, which we saw on satellite earlier, and it's starting to make its way over. And it's a positively tilted trough, which means we have a tilt that goes like this. So if this were a Cartesian plane, that's your y-axis, and this is your x-axis, and the slope of it is a positive number, so like this, we would call that a positively tilted trough in that respect. And that's just going based off of what we see on the map. And in a positively tilted trough setup like this, we would expect more of a overrunning flow, which is generally if these were all straight lines, like it was just like this, we would actually expect pretty calm, a nice like rain shield kind of event. But unfortunately, it seems that there's been a little bit more of a short wave that's developed. Apologies. It's starting to develop over the next couple of days, and you can see that it's tightening quite a bit at an area which is a little bit problematic, because whenever this 300 millibar wind jet max starts to come into the center and out into the east of the storm in the northern hemisphere, that's when we know that there's a significant amount of forcing that is going to be in play here, and any convection that comes will actually have a significant trigger and for anything underneath of it. So there's quite a bit of energy at play in the upper levels. It's going to anywhere that is diverging aloft like this means that air that if it's dispersing air in that particular region, denoted by these isobars that are gradually getting more and more spaced out compared to where it is at the axis, that means that the air is diverging away from one another in the upper levels. And the atmosphere does not like voids. It does not like empty space. If air is being dispersed in all directions, something has to fill it. And there's no air there's no air in the stratosphere right above it. So where does the air have to come from? It has to be sucked up from the lower levels, which means from the surface to the upper levels, there will be convection as the air gets lifted up into the atmosphere even further. So that is generally where the severe threat originates, and then we'll see how it progresses going into tomorrow. We can see more of a meridional flow, and this is very concerning, because whenever you see isobars that are going in this direction, based off a trough, and the trough has tilted more negative, right? That means that there is significantly more forcing in this particular regard. That's when we expect a pretty significant QLCS, or a quasi-linear convective system, so like a squall line in play. And it's usually indicative of a cold front as well. We might be able to see that a little bit more as we get down closer to the surface. But that's ultimately going to be the trigger. And then as that low starts to form and makes its way back over into the southeast, it starts to become more positively tilted again. So we can anticipate a slight amount of weakening, but the winds are still coming out of the southwest, and there's still going to be a significant amount of moisture in that area, which we'll see here in a second as well. Taking a look at what a particular hodograph will look like on Saturday over the Charlotte region. We take a look at quite a few things here. So when we're looking at a hodograph, we'll see a couple of important things. So I particularly like to look at bulk shear. Bulk shear or shear in general is very indicative of what kind of a severe threat that we are typically going to experience. So in this respect, we have shear levels that are relatively elevated pretty much through the entirety of the column. If they were constrained to only the lower levels and not a lot at the upper levels, we wouldn't expect a supercellular event. It would be more of a straight line wind event. In this case, we have shear going all the way through. We have very high storm relative helicity levels, so we would assume that, and we expect, what is that number? So it's well over 300 square meters per second squared. So we would expect probably strong rotating updrafts, and definitely an environment capable of producing a supercell. In that respect, we have our BRN, bulk Richardson number, shear vector number, at 137. Typically when that is, I believe when it's greater, actually no, if I remember correctly, BRN shear, yeah, so BRN shear, if I remember, yes, so that if it's over, I'm trying to remember from my mesoscale days, I believe if it's over 100, that means that long-lived supercells can be in place, particularly if it's in a discrete form, which is what we were expecting. We also take a look at what the rotation looks like at the lower levels of the atmosphere. This kind of like emulates our tornadic wind threat. So we do have a curve in the lower levels, which is typically in our hodograph. Hodographs are a little bit complicated to explain, but ultimately, if you're looking at this from a layman's perspective, when you see the red part, so the red denotes like the lowest 3 kilometers of the atmosphere, right? And you go up in elevation, and then the circles represent how strong the wind is. So we do have our curve, and we do see rotation that represents veering winds, or winds that rotate with height in a clockwise fashion, and it does exist, but it's just not very strong. If this were more of a like it comes out and it's like a straight line. So as you go further up in the atmosphere, in the lowest 3 kilometers, and it just is all in the same direction. And starting here, it's like nothing, and then it goes to 60 miles an hour as soon as you get up to like only 1,000 or 2,000 feet in the atmosphere, and then it makes a big curve like this. That would be your classic "we got problems" tornado situation, but we don't have that here. The speed shear is relatively low, and the curvature is there, but it's just ultimately not as pronounced. So there's probably still a threat for some form of tornadoes. We do have 3 Kate that's relatively elevated. That's the amount of convective available potential energy or juice for a thunderstorm to form in the lowest 3 kilometers of the atmosphere specifically. That is in the 30s, so that's about a moderate number. And then we also have D Cape is quite elevated as well. That's our downdraft potential energy, which essentially denotes whether or not we're going to have a big straight line wind event. And that, I think, is going to be our biggest factor as we move forward, just because that is such a big number. But ultimately, though, supercell in a discrete faction, so like storms that form right before the main cold front in the convective mode warm sector, is generally what I would be expecting out of this. And we could see this is coming from the 500 millibar vorticity map. So this is looking at Sunday at 6Z, so that is about we'll call that midnight on around midnight on Saturday, and or Saturday night, I should say. And we are looking, this is essentially looking at the energy ribbons. So like anytime when you're looking at a vorticity map, you want to see areas that have blacks and grays right next to areas of reds and yellows and oranges. If they're very close to one another, like tightly packed, like kind of like right here, we would expect to have there to be quite a bit of instability, and we can see the end result of which results in these short waves. So you see they're not straight lines, you know, they have little perturbations in them, and you can see coincidentally that wherever those darker, those more loud colors are next to each other is where those perturbations exist, and that's where we would expect to see some areas of convection initiation in those particular regions. If there is the right amount of moisture and the right amount of wind shear and other factors that also are coincident with that particular area as well. So that's why at 6Z we're experiencing our main problem areas in the Carolinas, at least, and northern Georgia and the central Piedmont of Virginia to be around that Saturday evening time frame at this juncture, according to the NAM. But we're also going to take a look at what we're looking at from a precipitable water perspective. So this is essentially taking a chunk. If you were to take a cubic meter out of the atmosphere, like just cut it out, you would be able to measure how many inches of water would be in that cubic chunk of an atmosphere. And obviously the higher the amount of water that you have in that chunk denotes how much moisture that you have in the atmosphere, and ultimately the amount. It kind of emulates just how much rain is available to drop if it had the right convective trigger associated with it. So you can see as we move forward here, this might be a little bit slow, but we can see across the entire southeast, there's quite a bit of moisture that it has been in place for quite a long time here this week, and you can definitely tell that obviously by just stepping outside. I mean, like, it's been warm and muggy all week, and that's just denoted by these precipitable water values, and it just goes to show that it's going to be the potential to rain is there. But as we move forward excuse me, into next week, you can see that amount of moisture generally moves out to sea, and it's replaced by a significant amount of cold or cooler and drier air coming in from the northern parts of the continent. So ultimately, it just kind of goes to show that we have the moisture in place in order for a major convective initiator to make its way here. We can also take a look at our 850, so lower levels of the atmosphere wind map. This will be a good indicator of what kind of a surface low that we have in place going forward into the weekend. So we can see that surface low really starts to ramp up on, 9Z on Saturday. So this is like 3 a.m. Tonight, and then tonight being Friday for listening to this at other times. You can see it really starts to wrap over Arkansas, Louisiana, and this is 18Z on Saturday. This is where we would expect probably around this time for the major. Because if this is 850 millibars up in the atmosphere, all the convection, all the discrete cells will start to appear right in front of where the major wind is in the 850 millibar level. So as we move forward, we're going to go to 21Z. That's probably in the Carolinas, at least, where we would probably expect the beginning of any convective initiation to begin, and the low will start to deepen just a little bit as it moves forward off into the Ohio River Valley. And you can see where the cold front is based off where the trough occurs, and cold air will follow quickly right behind it as we move forward into time. Now it starts to deepen as it gets into higher latitudes, which is totally normal, and some of the wind fields will expand as well, so we expect probably a little bit more of a windy day in general for particularly the flatter regions of the coastal plains of the Carolinas and Virginia. Going into tomorrow, along with probably another, if I had to guess, probably another line of storms that forms due to radiational heating going into the day on Sunday. But ultimately the main threat will be constrained into, for the majority of the southeast, and those problem areas that had the marginal severe threat in the Carolinas and Georgia and northern Georgia will be constrained to Saturday late afternoon into the early overnight hours. Take a look at what the NAM 3-kilometer convective model says as far as what they predict for reflectivity. This is what it expects the radar to kind of look like at the time, and you always have to kind of remind people, it's like, this is not what the radar is going to look like. The model is just showing, like, based off of what it sees in terms of all of its convective parameters, what the probabilities are that the type of precipitation or convective mode will be in place. So you can see that the problem areas start to show up here. I know they don't look like much, but whenever you see cells like this occur, and you notice from what we saw earlier by the SPC, the marginal risk extending in this particular green lip right here, that is right and coincident with where we see that convective discrete mode over those portions of the southeast. So, and we see the primary line start to form along the elongated surface trough or surface low that's coming in right behind it. As you move forward in time, this is hour by hour into Sunday nights, and it starts overnight hours. It loses a lot of its convective potential due to lack of heating, but ultimately the strongest of the storms will definitely be from pretty much the beginning of the day all the way on Saturday. We'll start to develop that quasi-linear mode as it moves forward into Alabama and northern Georgia. Probably dissipates by the time the sun goes down. Not dissipates, but certainly loses a lot of its convective strength before going into Saturday night. And late hours of Saturday night or overnight hours, general weakening, surface low will go over the Appalachian Mountains, and then as it shifts off and the main cold front trough starts to make its way into the last part of the Carolinas, it'll start to reform and begin another convective mode going into Sunday. But that day 3 mode does not seem to be as much of a problem. It just the SBC just has denoted a chance of scattered thunderstorms. Nothing is saying that it's going to be a major severe threat going into the next day. So that's what we're looking at. And we can take a look at what precipitation looks like. So precipitation we would expect going into, let's see, that's looking at the end of the system. So we're in the blues and pinks. So in some regions of South Carolina, depending on where those convective lines occur, you can get up to maybe 2.5 inches perhaps, all the way down to about 1/2 inch in the coastal plain of the Carolinas and southern Georgia. Florida seems to be a generally non-factor in this particular system, but we're looking at maybe 3 or 4 inches across the deep south in Louisiana and Birmingham, central Jackson, Mississippi, those regions. And the further west that you go in this particular region of the Mississippi River Valley, they're actually in quite a significant drought that needs quite a bit of rain in order to recover a lot of those tributaries and systems in those regions. So it's actually good they're getting the moisture that they need in this particular situation. But overall, I mean, if you're looking at a nice 1.5 inches of rain for the greater part of the southeast, I'd say that's probably a good prediction to go for. And then we see going forward into next week, the atmospheric river, as we talked about earlier, will start in the Pacific Northwest. And then as that jet maximum starts to make its way down further south and that diverging flow starts to move subsequently further south along with the deepening trough, we would expect to see the beginnings of the atmospheric river event to hit the southern portions of the west coast and into the southwest going into the end of next week. And that might continue for some time. ultimately, that shift in the jet extension will ultimately destabilize the weather going into the next week for us. And ultimately, we're in this 7 to 10 day pattern still of good weather, bad weather. And so this week we have bad weather. Next week we'll have, since we're seeing the end results of this week's jet retraction in the southeast, we'll experience some more geostrophic flow and generally good weather before we go back to bad weather as the extension occurs again, and we get put into this whole cycle over again. Ultimately, though, I mean, the main story I think that's understated here is cold air is generally not really here. We're very either seasonal and climatologically mild, which, you know, for some people that don't like snow or have had already enough snow, then that's kind of a good thing. But for us here in the Carolinas who are just begging for some kind of snow, it is unfortunately not looking good. I mean there's different teleconnections you can look at. I know particularly the one that a lot of people subscribe to in terms of disrupting the polar vortex, because ultimately you need the polar vortex to get disrupted. We need to get that cold Arctic air out of it, out of the Arctic Circle and back into the continents, in order for us to have any prayer of cold enough air to get some snow involved, potentially. But and there's various teleconnections: Arctic Oscillation, North Atlantic Oscillation, Madden-Julian Oscillation. Those are all things that we can potentially look at going forward. But ultimately, right now, if the polar vortex is looking as strong as it is, I wouldn't expect freezing temperatures to return to the southeast states for. It might, you know, here and there it might touch a low that might be in the mid 30s or so, depending on what everything looks like synoptically. But ultimately, I generally wouldn't expect freezing temperatures to occur en masse until the middle of the month at the very earliest, going forward, unfortunately. So we'll take one last look. We'll take one last look at the two flagship models and what we're expecting, and generally speaking, going forward. So we see our main system starting to ship off. That low center starts to go off the coast of the southeast, and there's a little bit of a snow chance, or I'd say quite significant of a snow chance for the New England states, as you know, that the low center gets off the mid-Atlantic coast and does its normal deepening 50 miles to the south of Martha's Vineyard in Rhode Island. Will essentially start to bring more moisture off the Atlantic and the Gulf Stream, and interact with the cold continental air mass, creating a little bit more of a snow threat up there. So they're definitely getting plenty of snow this season so far. And then we'll move forward in time to see what we're looking at maybe next week. Interesting little thing that I've noticed is that both models want a little, a tiny low to deepen across the Great Lakes region and maybe disrupt some of our weather patterns here in the middle of the week, particularly on Wednesday. And then another interesting thing to note, I mean, this would be more of a significant factor if we had colder air in place. But, you know, if it wants to form a low off of the coast by the end of next week, it would be like this. And ultimately, the strength of that low, so like how many isobars, how many of those lines you can get tightly packed together, will denote how strong that the cold air advection is coming from this region. Because if that low were to sit, you know, more close to the coast, like in its typical nor'easter area, like right there, and it was really tightly packed and whatnot, then we would get a lot of cold air that goes down and into the southeast, and then get dammed along the mountain range. And ultimately, that's what obviously we call cold air damming, and that is a very important precursor to being able to have the cold air in place at the surface in order for us to receive any precipitation here in the southeast. So, I mean, we talked about this at length, but ultimately we need the energy, we need the moisture, and we need the cold air all in place at the same time in order for the southeast to get any kind of snow, ice, or anything. In this particular scenario, this would be the scenario that would deliver the cold air to us in our typical fashion. Unfortunately, I don't think that the air is going to be cold enough, because it needs to be frigid over the northeast in order for it to stay that cold and be able to be dammed against the Appalachians. So it's just, we keep having like the right circumstances occur at different times, right? So it's kind of the name of the game so far, going into the rest of February. So And then we can take a look at temperatures. As I said before, they're going to be generally mild and very seasonal. You can see all of the Arctic air is being constrained up into the Arctic, up in the Hudson Bay regions. All those purples and whites and whatnot, they're very, very high up and north in the atmosphere. And then you can see us here in the southeast is generally just 50s and 60s, maybe 40s overnight. A little bit of a cold snap as we go forward. I believe that is middle of the week on Tuesday. That would coincide with the low that we saw, so that makes some sense. And then we'll warm right on back up. Nothing to the extent it looks like that we had this week. Maybe we'll touch the mid 60s going into next week at some point, but ultimately I think today is a little bit of an outlier in terms of temperature. So we'll definitely keep an eye on if we break any all-time records today, specifically in the Charlotte GSP region. I know Columbia is very close as well, so we'll definitely take a look at that. But I appreciate y'all tuning in today. Once again, my name is Zach for Great Atmosphere. I appreciate you tuning in. I do videos like this. I'm definitely I'm trying to get the right pace that coincides with both my work schedule along with just being able to produce good content and good topics over time. So I think I'm going to do Monday, Wednesday, Friday for uploads from now on, and in the mid-afternoon, and ultimately we'll just see how it goes from there. But ultimately, I appreciate your tuning in and your subscription. If you specifically live in the Southeast, I feel like these videos would be very helpful to you. And if you just like meteorology in general, I think it's obviously a great channel to potentially invest in as well. So invest your time in. So I appreciate y'all tuning in, and I'll see you next Monday for another video. Bye bye.